All right, so section 4.4 is all about writing equations of lines given certain features. Okay, so for number 4 here, we are given that for this line, point B at -4, -1 is on this line that we're going to determine the equation for, and the slope of this line is -1/2. So there's a few different ways that we could go about doing this. We talked about two forms of a line. So we talked about slope-intercept, which you're probably more familiar with in algebra. And then we talked about another form to write an equation of a line called point-slope form, which you're probably not as familiar with from algebra. So point-slope form is very useful if we have the slope of the line and then just some random point. Okay, so slope-intercept requires you to have the y-intercept to write this equation, but point-slope can just be used for any point. So point-slope form is going to look like y minus y1 is equal to m times x minus x1. So in this equation, m still represents the slope. The y and the x without subscripts just represents your basic y and x. And then the x sub 1 and y sub 1 are your point. So over here, I've got my slope of -1/2. I've got my point b, -4, -1. That's my x1, y1. So I'm going to take the pieces and plug them in. So y minus -1. So y minus -1 will become y plus 1 is equal to m, which would be -1/2, times x minus x1, which will be x minus -4, which will become x plus 4. So it's always going to be minus, but if your numbers are negative, then that's the only time it'll change to plus. So we have y plus 1 is equal to -1/2 x plus 4. So we want to take that -1/2 and distribute it. So we wind up with y plus 1 is equal to -1/2 x minus 2. And then lastly, when we get our y alone, so to subtract our 1 over, and we get y is equal to -1/2 x minus 3. So notice, we started out in point-slope form, and then we were able to work our way down into slope-intercept form, even though we didn't have the y-intercept to start with. Okay, and so that's another good thing about point slope form is that if you can get your equation of your line in point slope form, then you can work your way down into slope intercept, which is the form that we normally like using anyway. Okay, so continuing on with the same instructions, we are going to determine the equation of the line. So last time we were given a point and a slope. This time we're just given 2 points. So points B and C are 2 points that are on our line, and using just that little bit of information, we need to determine what the equation of the line is. So with the last one, we were given the point and a slope, and this time we're not given the slope, but we know we're going to need the slope if we're going to write the equation of our line. So the good thing is, if we got 2 points, we can determine what the slope of that line is. So my slope formula just being m is equal to y2 minus y1 over x2 minus x1. So I'm going to plug in these points. 2 minus 5 divided by -6 minus 3. That'll give me -3 over -9, which will reduce down to 1/3. So the slope of my line is 1/3. And so now at this point, I got a couple different options that I can do. I'm just going to stick with point slope form. So I'm going to pick one of my points and my slope, and I'm going to plug them into point slope form. So I picked my point -6, 2. So when I do that, I'm going to get y minus y1, which is 2, is equal to m, 1/3, x minus x1. So x minus -6 will result in x plus 6. So now I'll distribute my 1/3, and I get y minus 2 is equal to 1/3 x plus 2. And then lastly, add over my 2, so I wind up with y is equal to 1/3 x plus 4. And that is going to be the equation of my line. Once again, I started off in point slope form, and the good thing about point slope form is if you can get your equation in point slope form, you can then work your way down into slope intercept form.